I am now going to review slope of parallel and perpendicular line. Again, you may be watching this on Thursday or Friday. Today's objectives are students to be able to complete the steps to prove the slope criteria for parallel and perpendicular lines using coordinate grids or coordinate geometry. Students will be able to determine if two lines are parallel or perpendicular, and students will be able to use slope criteria to find additional points on a line parallel or perpendicular to a given line. Our students will be able to prove the slope criteria for perpendicular lines. Let's get started. Again, this lesson is titled Slope of Parallel and Perpendicular Lines, and this is Unit 3, Lesson 6. Now let's do a brief review of slope, which we saw at the beginning of Unit 3. Let us remember that slope is often referred to as the rate of change of a line, where we have the change in y over the change of x. It is also known as rise over run, where rise indicates what happens up and down, and run indicates what happens left and right. For example, we have this slope in this coordinate graph, and we can map the slope by seeing how many units down, 4, and how many units to the right, 5. And because we have a negative slope, our slope is negative 4 over 5. We can also use the slope formula to find the slope of a line. For example, here we have a point at negative 4 and 4, and here we have a point at 6 and negative 4. And so we plug that into the slope formula. And we'll see that we have negative 8 over 10, which if we simplify it by dividing those by 2, we have negative 4 over 5. Therefore, our slopes match. So we can either find the slope on a coordinate grid by doing rise over run, when it's reasonable to count up and down, left and right, or we can use the slope formula by using 2 points and then identifying the slope. Now, an interesting thing about slope is about the slope of parallel and perpendicular lines, and we're going to look at that right now. We learned about parallel lines. We know that parallel lines are two lines that are coplanar, but that never intersect. Well, the interesting thing about slope of parallel lines is that the slopes are equal to each other. So if we have two lines and we know that they are parallel, we can reasonably assume that the slopes will be equivalent to each other. As you can see here, our slope is negative 5 over 3, and here our slope is also negative 5 over 3. These two lines are parallel and they also have the same slope. This equivalence is indicated by this equation right here, where m indicates the slope of our first line and m2 indicates the slope of our second line. The reason we call it m, we'll get into this a little bit more on Monday, is because linear equations take the form y equals mx plus b, where m indicates the slope. So m always indicates the slope of the line. Now let's look at perpendicular lines. Perpendicular lines, on the other hand, again are coplanar lines that intersect at a 90-degree angle. Well, the slope of perpendicular lines are negative reciprocals of each other. And what a negative reciprocal is when you switch the fractions and then negate it. So I'll show you what this looks like. Again, here we can see we have slopes 3x and negative 1 over 3x. And so our slopes, using or remembering the y equals mx plus b equation, our slope is the m portion. So we have slope 3 times negative 1 over 3. And when we multiply those, we always get negative 1. So the interesting thing about perpendicular slopes is that this is the equation that we get when we multiply both the slope of line 1 and the slope of line 2. Those two slopes should always equal to -1. The reason being is because we use a negative reciprocal. What is a negative reciprocal? Well, as you can see, the slope of line 1 was 3. Well, in order to find the negative reciprocal, you need to create that into a fraction. So 3 over 1 is also equal to 3. And then what you'll do is you'll switch those. So you'll get 1 over 3. And then what you'll do is you'll actually negate it, giving you the negative reciprocal. If you just do the switch, it's just a reciprocal, but we need the negative reciprocal of the slope to get the slope of the perpendicular line. So, thus our slope is -1 over 3. We'll look at this a little bit further. Here we're asked to identify the slope of a parallel and the perpendicular lines. So, here we're given our original slope, and we're asked to find the slope of any line that is parallel to it and any line that is perpendicular to it. Well, we know that the slope of parallel lines must be equal to each other. M1 is equal to M2. So, we can say that our slopes will remain the same whenever a line is parallel to that original line. Perpendicular lines, on the other hand, are negative reciprocals, which are also indicated like this. In order to find the reciprocal, what we want to do is we have 5. Let me move this up. We have 5 over 1. We'll switch those, and then we'll do the negative. So we have our slope, -1 over 5, which is perpendicular to the slope of our original line. Here we already have it in fraction form, so we'll switch those and then negate. Here we have it in fraction form, so we'll switch those and negate. Here we have to put it in fraction form, switch those, and then negate. Same thing for this one. Switch those and negate. Again, switch those and then negate. Here we have it in fraction form, so we'll just switch them and then negate them. Here we have them in fraction form again, or not in fraction form, so we need to put in fraction form. So we switch those and then negate them. So, thus, we found the slope of any line which is perpendicular to our original line. Therefore, we have found the slope of any parallel line and any perpendicular line. So to our original line, every line which is parallel must have this slope, and every line which is perpendicular to that line must have this slope. And that follows for all these different slopes. Let's move on. Now we're going to review horizontal and vertical lines and determine what we know about horizontal and vertical lines. So we have horizontal and vertical lines. Let us recall that horizontal lines have a slope of 0 and vertical lines have an undefined slope. What does this mean? Well, this means that if we have a horizontal line, the slope of that line is 0, while if we have a vertical line, the slope of that line is undefined. Well, as far as parallel and perpendicular lines go, it's reasonable to assume that all horizontal lines are parallel to each other and all vertical lines are parallel to each other. What does this mean? Well, this means if I created more horizontal lines, all those lines would be parallel to each other. They would never intersect. If I were to create a bunch of vertical lines, all those lines would be parallel to each other and never intersect. However, if I had a horizontal line and then I created a vertical line, well then those lines would be perpendicular to each other and would actually intersect each other at 90 degrees, which is stated here. Horizontal and vertical lines are perpendicular to each other. So all horizontal lines are parallel to each other. All vertical lines are parallel to each other. But if I have a horizontal and a vertical line, then they are perpendicular to each other. Let us now look at the perpendicular transversal theorem. This theorem states if two lines in a plane are perpendicular to the same line, then they are parallel to each other. Well, what does this mean? Well, let me show you using this diagram. Here we have line K, and we can see that line K is perpendicular to line T, which is indicated here. There's an intersection of 90 degrees. Well, in this diagram, we can also see that line L is also perpendicular to line T, as it is indicated by this 90-degree intersection. Well, because K is perpendicular to T and L is perpendicular to T, it's reasonable to assume that K and L are parallel to each other, as we can see here. And so that is what the perpendicular transversal theorem tells us. Let's look at the perpendicular line transversity theorem. This one states if two lines are parallel to a third line, then they are parallel to each other. Well, what does this mean? Well, as we can see here, line E is parallel to line F, and line G is also parallel to line F. Well, knowing that, we can also assume that line E is also parallel to line G, and line G is parallel to line E because they are both parallel to line F. So this looks like E is parallel to F, G is parallel to F, so E and G must be parallel to each other. That is basically what the perpendicular line transversity theorem tells us. Now let's review. We learned that parallel lines slopes are always equal to each other. So we have two lines that are parallel to each other, their slopes must be equal. We also learned that all horizontal lines are parallel to each other, as well as all vertical lines are parallel to each other. As far as perpendicular lines go, we learned that the slopes are negative reciprocals and that any horizontal line is perpendicular to any vertical line. If you still have some confusion about this, I would go ahead and reverse this video and review those sections. Today's glossary terms were perpendicular lines, translation, slope, parallel lines, reciprocal, and rotation. If you have any additional questions or concerns about any material discussed here, please email me to my email listed here. I am happy to help you. Have a wonderful weekend. I will see you Monday.